So for this unit only, we will be doing both degrees and radians. This is your overlap unit. Listen well to me. After this unit, it will be only radians. We will not do degrees at all. So here's my pep talk. You are going to have to start to let go of the degrees. I always get a couple of people that want to cling on really, really hard to them and they won't let go. You will not be able to move forward. The entire rest of the year will be shot for you. Okay. This is your overlap unit where we do both. After this, radians only. Okay. If you're going on to AP Calc next year, we don't even touch degrees at all. It's not a thing. It's radians only. Cool. So here's your little, I mean, I'm not going to read this whole thing to you, but basically here's how it works. Pretend you're standing in the center of a track, like pretend you're out there on the track, except it's a perfect circle. Okay. You're standing in the middle and watching your friend run around, and this won't show up on the video, but I'm going to just stand here and sort of act it out. So I'm standing here in the middle, watching my friend run around this, pretend it's perfectly circular track. When I turn like this, do you see how that's degrees? Like I'm turning. How many degrees did I just turn? 360, that's the whole way around. Your friend running around the outside represents the radians. Do you see how they're both circular? You're both going around, but you're staying in one spot and just turning, and your friend is actually going around the circle. Are you understanding what I'm saying? Okay, I have to get this. All right. I'm not going to read this whole paragraph, but basically, every circle is a different size, and we have to make the radians uniform, so no matter what circle we're talking about, they're all the same, because otherwise a circle this size would have different amount of radians than a circle this size, which would be different than like the circumference of the whole Earth. We need them to all be the same. So what you do is you divide out the radius of the circle. If you divide by the radius, then it standardizes it, and you have the same radians no matter what the circle is. Here's the most important thing that you need to remember. So maybe like underline or star or highlight this. Remember, both degrees and radians are measurements for an angle. So degrees and radians are both measurements for an angle. The trig functions, which that's sine, cosine, tangent, cosecant, secant, cotangent, those are a ratio of the sides. Opposite over hypotenuse, adjacent over hypotenuse, and so on and so forth. Okay. Radians and degrees are the angle. Trig functions are a ratio of the sides, something over something else. Okay. Now the goal is for us to be able to convert. This is like converting feet to yards or feet to miles or moles to whatever it is you make moles go to in chemistry. What is grams? I don't know what that is. Grams and moles. Okay. But you know what I'm saying? Converting inches to feet. We're going to convert degrees to radians, you know, and so on. So radians to degrees. All right. So if you go the whole way around, you went 360 degrees, and I'm going to put the little degree symbol so that we know what we're looking at. Does anyone know? I'm just going to throw it out there and go fishing and see what I get. Does anyone know the circumference, bless you, formula for a circle? Because the whole way around in radians would be the circumference. Pi squared is the area, and I'm so happy you know that. That's awesome. I'm looking for circumference, though. Does anyone know there is a pi in it? 2 pi r. Good job. Now, we divide out the radius, though, because otherwise, if you kept that in there, it would be different for every size circle. So basically, we just get rid of it. Basically, they were like, okay, we're just going to get rid of the radius. So 360 degrees is 2 pi. It's once around. I'll act it out again. Degrees is this. I went the whole way around. Radians is your friend running around the track. The circumference is one time around. Okay, head's nodding. I love it. Okay. Now, to reduce that and just make the numbers a little bit smaller, you divide by 2. 180 degrees, that's halfway around, would just be what? Yeah, 1 pi. So this is your conversion right here. So to turn degrees into radians, you're going to multiply by pi over 180. And again, I suggest leaving the degree symbol in these because you'll get to see it cancel out, and that helps. To turn radians to degrees, you're going to multiply by 180 over pi. You actually can't mess this up because if you do it the wrong way, the pi's won't cancel or the degree symbols won't cancel. If you try to do it wrong, you're going to go, oh, whoops. You know what I'm saying? Okay. This is like your 12 inches equals 1 foot. Do you get what I'm saying? Like that's the conversion. What is it with mole? 1 gram is how many moles?
6.022 times 10 to the 23rd.
Oh, wow. I always bring that up because I know a lot of you are in chemistry at the same time and it's a conversion. That's what we're doing.
All
right. So we're just going to practice going back and forth. This is all that this is. All right. So for this one, you're going to take your 30 degrees. You're going to multiply by pi over 180. So take your 30 degrees, multiply by pi over 180. So look, do you see how the degree symbols cancel? Okay. Now the zeros also cancel, which is convenient. And you get 3 pi over 18. I didn't write it on the final answer line though, because that reduces to what? But where will the 6 be? On the bottom. So 1/6 pi, or pi over 6 is how we say it, but 1/6 pi. That's what we're practicing here, is just converting these back and forth, all right? So take your 90 degrees, multiply by pi over 180. The degrees are going to cancel. The zeros are going to cancel. And you get 9 pi over 18, which again is going to reduce to what? Pi over 2. Good job. 1/2 pi. I'm going to save this one for the last of these because that's going to be the hardest one. All right, let's go to 240 because it doesn't have a 0 on it. So for this, your degrees cancel and your zeros cancel. You get 24 pi over 18. Those will both divide by 6. I was going to say 3, but 6 is bigger. So that will be 4 pi over 3. Good job. It's basically fractions more than anything else. All right, and then try the 270 there, and then we'll go back and grab that one that's going to be a little bit tougher. Multiply by pi over 180. The degrees cancel, the zeros cancel. You get 27 pi over 18, bless you. Those will both divide by what? Bigger than 3. 9. Good. So it will be 3 pi over 2. Good job. So let's go back and grab this one. It's just going to not reduce as nice. So that's why I was like, here, let's just save that for last. You're going to multiply by your pi over 180. Do you mind shutting? Sorry, I was hoping the hallway would quiet down out there, but it's just not. All right, so the degrees are going to cancel, but unfortunately there's not a 0 that's going to cancel, and we're going to have to reduce. You can kind of do this however your brain does it best because you don't get a calculator. What I would do is just divide them both by 5. They might divide by something bigger, but I know they both divide by 5, so that's what I would do, okay? So if you can do 115 divided by 5 in your head, that's cool. If you need to do a margin problem, like take 115 and divide it by 5 off to the side, that's cool. Again, however your brain works, but you got to get through it somehow. I'll show you how to work it out if you need to. 5 will go into 11 how many times? 2. 5 times 2 is 10, then you subtract. Bring down the 5. We did long division with polynomials. Remember that? It was super fun, right? And then 5 goes into 15 3 times. So that's going to be 23 pi in the numerator. And then we're going to have to do 180 divided by 5. That one's going to not be quite as hard because there's a 0 at the end. 5 will go into 18 3 times. Will that be 30? 36. Now, I'm going to go ahead and tell you this, and you can do what you want with this information, but you're going to do 180 divided by 5 often. You're going to do that one a lot, so you might want to just remember that that one's 36. I'm just throwing that out there, okay? Like you're gonna just do that one a lot, and after you do it enough times, hopefully you'll just go, oh yeah, that one's 36. And then your life will be a lot easier. All right. That doesn't reduce because 23 is prime. So that's the answer. 23 pi over 36. But I just grabbed 5 because I knew they both divided by 5. Sometimes you might need to reduce again. And then that's just fractions. That's not really pre-calc, that's just fractions. So sometimes life is like that. You'll be okay. Now we're going to go backwards. So you're going to take your pi over 4, and instead of multiplying by pi over 180, you're going to multiply 180 over pi. And again, you almost cannot mess this up because if you put it the other way around, the pi's are not going to cancel. So now you get 180 over 4. Again, you can do that off to the side. You can try and do that in your head, but somehow you have to do 180 divided by 4. So I'll work it out the long way in case anyone needs to see that. If you can do it in your head, that's super cool. That thing's so loud. 4 goes into 18 4 times. And then 4 times 5 is 20. So 45 degrees. And I even put the degree symbol for you. Good job. That was really well said. Yeah, so like when we convert from degrees to radians, the degrees go away because we want it to be in radians. When we convert from radians to degrees, the pi's go away. All of your radians should always have a pi in them. It'll be like something pi. This one you actually don't have to do any work for because this is your conversion. It's kind of like if I asked you like what 12 inches was, you would just say 1 foot. Pi is 180. I put another one like that on here just to see if you're paying attention. Do you see another one where you can kind of just write yeah, so 2 pi is, that's the whole way around. So 360. 2 pi is the whole way around. 1 pi is just halfway around, 180 degrees. All right, so let's try this one. 10 pi over 9, you're going to multiply by 180 over pi, and the pi's will cancel. Now, again, you can get through this however your brain does it best, but I'm going to show you a little trick. Or not a trick, but just like an easier way to think of it. Keep the 10 there. Just keep it. Times, and do 180 divided by 9 first, because that will keep the numbers littler for you. If you do 10 times 180, you're going to get 1800, which if that suits you, then that's fine. But I think this goes better. 180 divided by 9 is 20. And then 10 times 20 is 200. So I think that's a little bit, it's not a trick. It's mathematically how it works, but I think it's an easier way to handle it. All right, and then last one of these, 16 pi over 9, you're going to multiply by 180 over pi. Bless you. Bless you. So pi's cancel, and again, I would just keep the 16 there. And do 180 divided by 9, which again is 20. You okay? Bless you. Now, how I would handle this in my mind, since you don't get a calculator, what's 16 times 2? 32, and then just put the 0 back, so 320 degrees. It sounds like you're preheating your oven or something. So that's how you convert between degrees and radians. Okay, I know you think you know what an angle is, and you do, but we're going to do like the more grown-up pre-calculus definition of what an angle is. So an angle is formed by rotation. This is formed by rotating a ray about its vertex. There's a lot of vocabulary in there, so we're going to talk about it. Do you remember from geometry, you did segments, lines, and rays? A segment means what? It has 2 endpoints, stops on both sides. A line means they go forever, but a ray means like one side has an endpoint and the other one looks like a clock hand. Do you know what I'm talking about? Okay. Oh, usually I get like a paper clip and I use it to show the rotation. Hold on, let me go grab a paper clip. All right, so I'm going to show you how to write them in standard standard position. This is your XY axis. This is your origin 0, 0. And so let me use a different color here. It won't really show up on the projector, but we'll try. This is your initial side. And what does initial mean? The start. Initial just means the start. Okay, so we're going to start there. And then watch me do this. I just grabbed my paper clip. We're going to take that ray and we're going to rotate it. Do you see how I did that? Okay, so it's going to go like that, and it's going to create an angle. Wherever you stop is called the terminal side. So initial is starting, terminal is ending, and this is your angle, and we call angles theta. It looks like a little Easter egg.
Is that what it's terminal?
Yeah, ending, yes. Initial and term, that's what that means. Okay. So if you start here, you have rotated nowhere. That is 0 degrees, which is 0 pi, no pi. We're going to go around and do the like compass point ones, your north, south, east, west. All right. So watch, if I rotate up to here, what is that in degrees? That's 90 degrees, which is pi over 2. You are going to need to know these. Okay, notice I didn't say memorize, I said know, and there's a difference. We're going to talk more about that. All right, so watch. If I rotate all the way to here, how many degrees did I go? 180, which is 1 pi. Hold on. You can put in your pause. Oh, yes. Thank you. All right. If we start here, this is where they all start. That's your initial side. If we rotate all the way down to here, how many degrees would that be? Be 270. Good. How'd you get 270? Because that is correct. You take 180 plus 90. Okay. Now the pies, this is a half a pi. This is a whole pi. So this is 1.5, but we do not say that. It would be 3 halves. The other way you can think of that is 1 half, 2 halves, 3 halves, how you're counting. Now, if you go the whole way around, that would be 360 degrees, which is 2 pi. Now your quadrants. This is 1. This is 2. This is 3, and this is 4. And they are Roman numerals. So don't put something that's not a Roman numeral. Now look, did you ever wonder why they were labeled like that? Like, why is it this one 1, and then that one 2, and that one 3, and that one 4? That's how you read, is left to right. Did you ever wonder that? The reason that they're in that order is when you rotate, which quadrant do you get to first? 1, and then 2, and then 3, and then 4. That's why they're like that. All right. Positive angles rotate starting up. So if you start here and go up, that's positive. Negative angles rotate down. So if you start here and you go downwards to start out, you're going backwards, that is a negative angle. So yes, you can have negative angles if you go backwards. So we're going to do the conversions for these, and then actually, you know what? Did we do enough conversions over here? Have you got the conversions? Okay, then we're not going to convert them. We're just going to practice drawing them, because that's really what I'm trying to get across here. There are only, let me stand up because it's important. There are only 4 quadrants. If you get stuck, pick one. Okay, there's only 4. Also, I'm not going to get out a protractor and make you measure these to be exactly perfect. You just have to get it in the correct quadrant, and you have to get the direction correct. All right. So 45 degrees. If you start here and rotate 45 degrees, what quadrant are you in? 1. I want you to draw me something in quadrant 1 and show me that it went this way. That's all I want. We're just practicing drawing them. That's it. You just see the rotation.
Like our answer, like on a
That's
test,
it.
just be that.
If I ask you to, if the directions say draw the angle, I want the quadrant and what direction you went. So 210. What quadrant is that going to land you in? 3. So it would look like this. Yes, the arrow always starts here. This is your initial side and takes you to your terminal side, starting and ending. All right, this one is negative 240. So here, I'll show you with my paperclip. We're going to start here, but we're going to go backwards 240 degrees. Where is that going to land you? Second quadrant, and it's going to look like this. Yes. Now listen, this is where I get people that want to convert from the radians to the degrees and stay in degrees. You have to start to let go. You have to start to let go, because after this unit, we're not touching degrees anymore. You're going to have to start to think in radians. All right. 3/4. Sometimes I don't always say the pi because it's a mouthful verbally. All right. 3/4. You just want to think in your fractions. This is a half, and this is 1 whole pi. So do you see how 3/4 would be in between a half and a whole? Half a pi and a whole pi, 3/4 would be in between. So quadrant what? Quadrant 2, good job. You just need to think in fractions is what it is. All right, negative 1/3. Let me pull this back up here. We're going to go backwards this time. This would be negative 1/2 if you go down to here. That's negative 1/2. So if you only go negative 1/3, what quadrant are you going to be in? 4, good. And you went backwards, so it's going to look like this. Again, you just need the quadrant and the direction. We're not going to get out a protractor and measure these. It's not going to be like perfect, okay? All right, 11 pi over 6. Here's how I think of that. 12/6 would reduce to what? Because this is really close to 12. 2 pi is the whole way around. So you almost went the whole way around, but not quite. 12/6 would be 2 pi the whole way around. You almost made it the whole way. So what quadrant are you in? 4. You almost went the whole way around. And I like that one because it looks like Pac-Man. So basically what you want to think of, let me recap it before we go to the last page here. This is a half, this is a whole, this is 1.5, and then this is 2. You're just trying to see like where your fraction landed in between those is all that you're doing, okay? But you guys handled that really well. That went good, okay? Coterminal, and we're going to do some vocabulary here. Coterminal, it means they have the same terminal side, but different amounts of rotation. So they end at the same spot, but different amounts of rotation. That's like this. You're out on the track, but pretend it's a perfect circle. You do 1 lap, and your friend does 9 laps, but you all end at the finish line. So you end at the same spot, but do you see how your friend went a whole lot further than you did? So they end at the same place, but they rotated, different amounts. So we're going to draw these and then state a positive and a negative coterminal angle. So what quadrant is 150 in? 2, good. You start here and rotate 150 degrees. You're going to be in quadrant 2. Now, if you want a positive coterminal angle, you just add a rotation. So look I will try to act it out as best I can, but my hand doesn't go the whole way around, all right? So if you go there, but if you add on 1 more rotation, I know that was sloppy, but do you get what I'm saying? All right, so we're going to add on 360. We're just going to add them together, and that will give us a positive coterminal angle, 510.
So that's like that 510 would be like your friend.
Going an extra lap. Yep, exactly. Now, if you want to go negatively, that's like you go that way, I'll go this way, and we'll meet on the other side. Do you see what I'm saying? Mm-hmm. So your negative coterminal angle is going to be this one. How could I get that? The one that I did with a dashed. Good. Now, listen, though. You are going to subtract to get that amount. Just slap a negative sign in front of it to show that you went backwards. Do you see what I'm saying? Okay. So if you subtract these, it's 210, but put that negative there to show that you went backwards. Because technically it should be 150 minus 360. Subtracting a rotation. Okay, good. Head's nodding. I'll take it. Do not convert this to degrees and then do the problem. You have to learn to let go of the degrees. We're going to think in fractions, okay? 4/3. I need what quadrant 4/3 is going to be in. Watch, I'll act it out for you. This would be 1/3. Here's 2/3. Do you see that? 3/3 is 1 whole pi. Do you get that that's right here? 3/3. So if I do 4/3, quadrant 3, I'm going to do it again. 1/3, 2/3, 3/3 is the 1 whole pi. That's 4/3. Because 3/3 reduces to 1.
Oh, okay. Yeah.
So you want to think of the compass point ones and like, did I go a little further than it? Did I not quite make it? You want to think of those up, down, left, right ones and just where you fell in relation to them, right? So what is 1 whole way around in radians? Let the degrees go. Degrees is 360, but I want radians. 2 pi, good. We're going to do the exact same thing that we just did, except with fractions, all right? 2 pi would be how many thirds? Because I need a common denominator. Good, perfect. I didn't even have to pull teeth with that. All right, so you're going to do 6/3 plus 4/3. I'm adding a rotation. Go ahead. Yes, however your brain does it is fine. But you have to understand, I'm saying it to an entire group of people. This is where teaching is kind of difficult because you all think differently and I have to get you to all understand the same thing. So I try to make it very physical and show people so that everyone can understand it. A right answer is a right answer. Okay. Do you get 6 plus 4 is 10? I kind of just wrote that while I was talking. All right, now if it's like, hey, you go that way, I'll go this way, we'll meet on the other side. All you do is subtract and just make sure you slap a negative in front of your answer to show that you went backwards. So this is going to be what? Negative 2 pi over 3. So you just want to think in fractions is all that is, right? Other piece of vocabulary. So that was coterminal. That means you just end at the same spot. Reference angle is the acute angle with the x-axis. It is always the x-axis. Think like the horizon of the earth, okay? It's always the x-axis. And please listen to this part because this is the thing people do mess up. It is always positive. Just by definition, there is no such thing as a negative reference angle. Okay, so we're going to draw these and then state the reference angle. What quadrant would 45 degrees be in? First, good. It's going to look like that. So if you're in quadrant 1, your reference angle is the angle. This is your reference angle. And for the reference angle, we put like a little prime with it. So if you're in quadrant 1, the answer is the question. You didn't go far enough for it to be anything different.
You need to have the 1.
That's a prime.
Oh.
It's like a little apostrophe. It's denoting that it's the reference angle. That's kind of where you may have seen that before is in geometry. Do you remember when you had triangle ABC and you shifted it over and it became A prime, B prime, C prime? That might be the only place you've seen that before, but it just means it's something different. It's kind of like I can't call it theta.
Yeah.
Because you can't use the same name twice, right? What quadrant is 210 in? 3. Good job. So look, your reference angle is with the x-axis. It's this amount right here. So look, if you went 210 and right here is 180, your reference angle is 30 degrees. Why would it be 30? And I heard you say 30 back there. 180 plus 30 gives you 210, or 210 minus 30 is 180, or however you want to think of that. It can't go over 90. Yeah, it has to be acute. All right, negative 5 pi over 6. Again, if you're able to just figure this out, that's cool, but I'm going to act it out for everybody. We're going backwards. Just watch. Negative 1/6, negative 2/6, negative 3/6, negative a half, negative 4, 6, negative 5, 6. Do you see how I did that? 6, 6. It always sounds like I'm lisping when I do that, but 6, 6 would be halfway around. We just didn't quite make it. All right, so quadrant 3 is going to look like this. Radians are great. Listen to me. Your reference angle for radians will either be pi over 6, pi over 4, or pi over 3. And the denominator just matches. It will just be one of those, okay? This right here is your reference angle. It's where you meet the x-axis. And this one's pi over 6. If this is 5, 6, you have one more 6 to get to 6, 6. All right, last one of these. Radians are easier once you get on board with them. I get that you're just learning it today, so it doesn't feel like that right now. Give it a couple of weeks and you'll be done with those degrees. Radians are so much easier. All right, 7/4. What do you guys think for what quadrant you're going to land in? Good. 8/4 would be 2 pi, which is the whole way around. You just didn't quite make it. The one that looks like Pac-Man. So your reference angle is this one. It's the part that Pac-Man is eating. It's with the x-axis. And it is pi over 4. If you went 7/4, you have one more 4th to get to 8/4. All right, and then these last two are these two little like formulas that you need to know. Arc length, I don't know why they use S for this, but it is S. It's the easiest formula ever. It's just the radius times the angle, r theta. Now here's the thing though. It needs to be in radians. So if it's not in radians, the first thing you have to do is convert. So we're going to practice one more conversion here. So we're going to take our 225. What do you multiply by to turn into radians? Does anyone remember? Or you can flip back because you only just learned it. Pi over 180. And you'll see how the degrees will cancel. I would just divide them both by 5. We might have to reduce a second time, but I know they both divide by 5. So 225 divided by 5 is going to be 45 pi. Does anyone remember 180 divided by 5? You do that one a lot. It's 36. Good job. Now that is going to actually reduce again. Those will both divide by 9. Good job. Perfect. 5 pi over 4. So to get your arc length, you just take the radius, which is 5, and multiply it by the angle. Here's where people do lose their minds. When you're multiplying fractions, you just multiply the top and multiply the bottom. If you need to put this 5 over 1 to help you remember that, you can do that. This is going to be 25 pi over 4. And what were our units? Inches. Can I show you, can you humor me for a second? Because this isn't actually an applicable thing. I'm going to show you what we actually did. What quadrant is this? It'll take 3.5 seconds. I just want you to learn something. What quadrant would this be in? 225? The third one, here's your circle. What we found is this distance. Do you see that? What I'm highlighting? From there to there. You've never been able to do that before. You've only been able to find distances of straight lines. We just found the distance of a curved line. It's cool. Neat, guys. All right. And then a sector area. Your area is 1/2 r squared theta. And again, it needs to be in radians. So if you're not in radians, that's the first thing you do. I gave you this one in radians, though, to be nice. Now, after I finish this, don't stop listening to me because I'm going to draw you pictures so you can understand what you actually did. All right. I gave it to you in radians, so we can just go ahead and plug into the formula. 1/2 r squared theta. What is 5 squared going to give us? And I'm going to write 25 over 1, because again, people lose their minds with the fractions. And then times the 2 pi over 3. You just multiply all the tops, multiply all the bottoms. That's all it is. So, oh, actually, the 2's are going to cancel, though. Can we just cancel those out? Well, I'll make that easy. 25 pi over 3. Now it's an area. Yes, but it's centimeter. Yeah. But the squared is the part I was mostly concerned about. All right, watch. 2 pi over 3 is going to be in what quadrant? Think about it. The second, good job. So it's going to look like this. And what you found is this area. So you found you've been able to find areas of triangles and stuff like that. Now you found the area of a sector. You could find the area of the amount of pizza you ate.